environment, what two methods are used to make ATP from glucose? So there are two general methods in which we use to make ATP in the cell. We have substrate level phosphorylation, and we have oxidative phosphorylation. Okay. Substrate level phosphorylation you can see in figure 7.4. Figure 7.4. While oxidative phosphorylation involves the use of ATP synthase, and you can see the actual protein, membrane protein in figure 7.15. Okay. Now, substrate level phosphorylation, and again you can draw this general diagram on the board and have your students explain it. It's 7.4 essentially shows you the last step in glycolysis, the 10th enzyme used, which is pyruvate kinase. And the way that I'm going to go through glycolysis is through the use of these enzymes. Now, they don't have to memorize the names of the enzymes by any means, or the names of these substrates, but to be able to really understand what's going on in the process, you should be able to understand it step by step by step to see how all the products are basically made. Okay? Now, with substrate level phosphorylation, it's one of the ways that we're able to make ATP, make energy. So, here you're using this basic concept of the substrate enzyme complex to make ATP. In figure 7.4, you're using PEP, phosphoenolpyruvate, sorry, phosphoenolpyruvate. Let me check. It's late. Phosphoenolpyruvate, PEP. Okay, so PEP at this point is a phosphorylated molecule. It's a high energy molecule, and so this high energy molecule is able to pop out that phosphate group that it has and attach it onto an ADP molecule, as you can see in figure 7.4. You're going from the high energy molecule to the low energy molecule, and that's essentially where what the kinase does. It phosphorylates the low energy molecule. It takes that phosphate group from the high energy molecule and gives it the low energy molecule. So the pyruvate kinase, here the kinase by definition is an enzyme that phosphorylates, gives the phosphate group from the high energy molecule to the low energy molecule. Pyruvate part, well, at the end you end up with the molecule pyruvate, okay, which, as you know, is very important as far as the products go at the end of glycolysis. So pyruvate kinase takes up the phosphoenolpyruvate, the PEP, okay, which is your high energy molecule. It takes off the phosphate group and adds it to ADP to make ATP. Okay, so that's one of the ways in which you're able to make ATP, and a specific example of substrate level phosphorylation. Now, oxidative phosphorylation is a lot more efficient as far as the production of ATP. You're able to make about 32 ATP with this particular enzyme, using its rotary motor powered by proton motor force. Okay, that basic proton gradient, which is formed in the intermitochondrial space through the movement of the electrons through the electron transport chain. Okay, and you see that in figure 7.15, which occurs at the end of the ETC process, and that's again oxidative phosphorylation. Okay, you'll go a little bit more into detail as far as the process of the ETC once you get into the Miss Frizzle.